All right, so welcome to Tuesday, May 19th. We are hanging in there. It's been a time, and we're doing well. Everyone, I hope, is doing well. I may or may not have an adult beverage in front of me. Just saying. But yeah, I'm really excited today because we are going to talk about science in the TV show Dark Matter, which is objectively awesome and I'm super excited about. Now, I just want to say this up front that if you are watching this after the fact on YouTube, please make sure you like and subscribe because I'm going to need some numbers. So that's how it works. And all of my social links and everything is down below if you haven't checked those out before. But without further ado, I really wanted to talk about the blink drive. That was kind of the main thing I wanted to discuss from Dark Matter. I had a couple of my patrons ask about it, and typically we try to pick specific episodes that at the very least, if it's like a series you haven't seen, that you can go and just watch those and kind of understand what we're talking about. And so I kind of mined the Dark Matter episode list for the best ones that we could talk about, and it's the first two where they find the blink drive. So if you haven't seen Dark Matter, I highly recommend it. It's in the US, it's on Netflix. Very good sci-fi. Just, for me, it's like if Farscape and Firefly had a kid. That's, for me personally, that's kind of how I loved it. It was taken off the air too soon, but it's still worth watching for sure. Just great storytelling. And they did some awesome stuff in here. Awesome stuff. The blink drive being one of them. So the overall plot of these two episodes, this was season 2, episodes 7 and 8, called She's One of Them Now and Stuff to Steal, People to Kill. And I kind of joke because in the first season, when they didn't know who they were, the episode numbers also don't have names because the characters didn't have names, which I kind of love. But then they made up for it in season 2. So I was definitely using up my Twitter character space posting stuff about this. But essentially what it is that they've been trying to seek this piece of technology and trying to figure out what it is. They know that big baddies want it. And they're trying to get it so they can get some answers. And what they have figured out leading up into this episode is that they figured out that this key, this piece of technology, allows access to interdimensional space-time. That's all they know. So you can see why I picked these. And cutting into that, so they're going to go try to find this key. They're going to try to go get it back. And what they're trying to do is, I hope it didn't freeze. Oh, okay. No, it's just catching up. What they're trying to do is track this person that has them. So Alicia Raynaud is the character, and they're trying to track her locations. So before we get into the science of the blink drive, I want to talk about this method of travel that they use called transit pods. And when you first get a glimpse of these, they're kind of like sunbeds. and the character 5, whom we love, is trying to track this Alicia's position using the subspace address of these transit pods. So there is a link that has been established, and they're trying to find where she is and where they can get to them. So they talk about these transfer protocols, which I love, because we've spent a lot of time talking about how transporters in Star Trek would work. And the answer is, how does transporters work? They work. Thank you for asking. And, whether it's like breaking you down into your material, figuring out where all your particles are, and then either sending that information as data, like saying, computer, like over the subspace information, whatever, that they send that information as data, and then you're built out of organic matter on the other side. So in theory, you could have, to Rikers, for example, or they send the particles themselves. They break you down into your tiniest particles, map where everything is, send the particles themselves, and then rebuild you out of that matter. And Star Trek kind of goes between those two explanations a lot, in the best way, but a lot. And so we have like the two Rikers example, and then we have the episode Counterpoint, where they're storing all of the empaths in the pattern buffer, like literally storing them, and they start to break down, having been stored and brought back multiple times. So those are kind of the two main examples of the different explanations that we get for how transporters work in Star Trek. Here in Dark Matter, oh lordy, they go into great detail, excellent detail, about how you could have transporter-like technology here. So they essentially have these transit pods, these transit sunbeds, and how it works is that they get into these transit pods, they close the hatch, and they stay there. But what the transit pod does is map where everything is, but instead of breaking it down, it's just mapping where all the particles are, and then on the receiving end, building a clone of that person wherever they're supposed to be. And there is heavy plot here that is utilized in these stories that basically says, okay, so how does the original person in the transit pod know what their clone is doing? And the answer is they don't. What happens is that the clone has to get back to the transit pod, activate it, get into it, and that transfers the memories back to the original person, who uploads the memories and then gets out of the pod safely. Now, if that clone doesn't make it back to the transit pod in order to transfer the memories, then and they get killed, they just like disintegrate. So it's pretty, kind of like the Matrix. That's a good analogy for this. But the bodies like completely just disintegrate and disappear when they get back, when they get killed, or when they go to the transfer pods. So yeah, you got to get back to the landline. Exactly. And the important thing here is, too, that in order to sort of transfer, you need those locations. And 5 starts to go into the detail. And they're basically like, yeah, you're showing off, aren't you? Just like, yeah, it's hard. It's hard to make these connections and be able to transfer through those. So, and when the clone gets back in, it basically kills them. Transfers the memories and then kills them, disintegrates it, and recycles the matter. I love this. I think this is brilliant. Now, if you've watched Dark Matter, obviously there's lots of layers with this here. Now, if the clone gets killed before they make it back to the transit pod, then the original person wakes up and all those memories are lost. Like, they literally have no idea. The last thing they remember is getting into the pod on the original side. So that's a great use of all of this. So the key is you got to get back so the original person remembers this. So their plan is to go and basically get intel on this technology to try to figure it out. They're like, this is a purely investigatory mission. We're not trying to take anything, and only organic matter can travel through. So we're going to learn things. We're going to go try to figure out what this device is. Another interesting, let's just speak of the organic thing, another interesting layer that I really love about this is that they have, because it's kind of like thinking about, we always joked about Transfiguration in the Harry Potter series. Like how their clothes sometimes stay with them and sometimes don't, and then would also have to scale. They kind of answer this here, where they're wearing super tight clothes that are specially for these transit pods, and they say that they are made of biosynthetic material. So it's organic material that is meant to be used for these, so they're able to do it. Oh, thank you, Joshua. So it's I love it. I think the explanations are really well thought out. All the in-universe stuff with it is perfect. Now, the key here, too, is that as they were going on this fact-finding mission, they did have a special escape, must get out, everything's gone wrong scenario where they have a shuttle pod basically hovering above to try to get them out if they need to. And that does end up needing to be used. Before we get ahead of ourselves. So 3 characters, they travel over. They do make the connection. They get to this hub, and they're able to get their hands on this technology. Before they get their hands on the technology, she hacks into their computer frame to try to figure out what this actually does. And she discovers that it's a blink drive. And I did not put it in here enough. Yeah, I did not add it to my stream. Darn it. The image is perfect. I will tweet it. I will post it on the Patreon page as well. I lost my brain when she discovers what it does and shows an image of it. So, yeah, you were 100% right. Yeah, you sent me a message and said, oh my gosh, I bet you love this. So, what it is in dark matter, they're traveling through the galaxy, between star systems, they have sublight engines, normal engines, not physics-breaking anything engines, and they have FTL engines, so they can go faster than light. The way they describe their faster than light engines is warp drive. They're basically saying, I think, did I write this down? Yeah. They said normal FTL creates a distortion in space-time to go faster than the speed of light, basically pulling the ship with it. But you are actually moving from point A to point B. You're just sort of condensing space-time around your ship so you're able to travel. It's warp drive. What they discover this technology is something called blink drive. And the key that they've been chasing down is part of that drive. What it does is, she said, the way 5 describes it, she says it creates transversible wormholes by accessing pockets of interdimensional space-time. I love me some good technobabble. But effectively what it is it's saying, and they just, okay, I memorized this. If you didn't watch this, if you're just here checking it out, which is totally fine, you're more than welcome to. If you are able to watch season 2, episode 7, just fast forward to 16 minutes into the episode for this explanation, because it is so good. And if I could play it for you, I would, but I don't want to have my channel get taken down. So just gonna have to trust me on this. But the way she describes it is so good. Basically, you want to go from point A to point B. Normally, you'd use FTL to travel there. It still takes time. The ship still has to move. What the blink drive does is fold the 2 points in space-time together, and then you effectively don't move. This blink drive happens, and then you end up at point B. It's a jump drive. It is the Battlestar Galactica jump drive. The same sort of technology. Yes, exactly. See? We're on the same page. I love it. It is just like the jump drive. And in fact, we don't really see that much in science fiction. We tend to have more traditional wormholes that are sort of stapling 2 points in space-time together and traveling through them, or warp drive. But these idea of jump drives or blink drives, where you take 2 points, fold them together, jump, unbend, lay it out like that, is really only described in Battlestar Galactica and in Dark Matter. And like I said, the imagery is perfect for it. The way they show the 2 points in space-time folded over and jumping, beautiful. I will post that image because I can't get enough of it. It's just fab. It is just fabulous. So, I mean, what they're saying is, plot-wise, this is a big deal because this is technology that has not existed in the Dark Matter universe storyline. They're like, if the baddies have this, that means they can jump to anywhere in the galaxy at any time, and that would be a game changer for good guys or bad guys. So, yeah, the same question remains about what happens to the air of space-time in between that. So they're showing, obviously, like, 2 points that are close that fold over and then they jump. And what happens if you live along those lines? And honestly, I think it's still kind of a scale thing. And it's so hard for us to kind of wrap our heads around that analogy of taking this flat trampoline but it really describing 4-dimensional space-time. a way to there's multiple ways to think about it. One is to try to extend your mind to try to think about this as a higher dimensions. So I've used the example before, not necessarily with a trampoline, but if we take it up to mattress springs and you instead think about space-time as just a bunch of mattress springs pointing around, if you're able to take one point, pull it through to another point, and jump, you're still going to get all of these bits in between that are sort of extended and warped a little bit. But then, to carry on that analogy, if you're able to picture the scale that we're talking about, right? We've had this discussion recently. Space is big. Space is very, very big. And so your local distortion to space-time, like a... that's okay. Your local distortion of space-time is probably not going to be noticeable. It's like if you're standing on a really huge, flat surface and, extends as far as the eye can see, and it starts to bend, but it's so massive that you can't, your little area, your vision, you're not going to actually see that bend. It's the same reason we don't know how our universe is really shaped, because we can say that it's flat to a certain extent, but we don't know. Oh, thanks for the follow. An awesome username, Sci-Fi Metal Girl. I feel like we'd be friends. It's a scale of difference, right? So we can say we know that our universe is flat to a certain percentage, that we're 99% sure that it's flat, but we don't know if we are just tiny bugs on a massive beach ball. So it's all about the scale. Now, if we really want to get into it, I appreciate the question, and I know I'm kind of giving a little bit of a half-assed answer there, because I haven't done the math to know how distorted space-time would be on a planetary scale, but we'll put that on the to-do list. I feel like if I have a day where I have a really good burst of energy and really want to math something, which no promises these days, I will try to do that, and I'll just add that to the list because I love it. It's a really good question. So thank you, and noted. But like I said, I love the imagery that they use here, and they do kind of talk about a little bit how there must be some limitation to it, but it's more a matter of mapping out and knowing where you are. It is a mood thing. Sometimes I find math very calming, but it's also daunting, where it's like, once I'm in the zone, it's a happy meditative spot. If I'm not in the zone, then it's like, oh God, I gotta start that. So they have this, they find out that that's what this technology is. This is a blink drive that will irreversibly change how, their world functions. Essentially, that if you have a drive, and they say galaxy, universe a little interchangeably here, which they're not wrong, but sort of sciencing it a little bit. They do mostly just say galaxy. So they've established, and they have star systems that are sort of named, they're essentially in the Milky Way galaxy, in our local star system-ish. And so they say, okay, if we had this blink drive, and it took no time to travel anywhere, you could theoretically go anywhere in the galaxy in the blink of an eye. That would be bad. At one point, there's one line where they say, oh, we could travel, we could go anywhere in the universe. And I think that would probably be limited, not necessarily by the science of it, but more the energy it requires to do that. Because they talk about how this blink drive is able to interface with standard drive systems. And standard drive systems are going to have a limit. They're going to have an energy cap of how much energy they have. And so, like Battlestar Galactica, they're spooling up their blink drive. It takes energy, and that energy is going to be a limiting factor on how much space-time you can bend together. They don't go into that too much. But that's just what I'm saying would be a limiter into the travel that they could do. So they find the technology itself, and they go and actually get it, and they get caught. So bad things start to get tortured, and going back to the transit pods, the transit pod science. The big baddie, Alicia, is Renault, is essentially saying to the two guys, so two guys and a girl's taken off, two guys there. I know not a lot of you have watched Dark Matter, so I'm not going to worry too much about the character names. But they are being held hostage. She found them, she's torturing them, and they're basically like, do what you want, lady, because it might hurt, but we're still going to be alive. And she's like, oh, ha ha, I've found a way to not keep you alive by sending a subspace reverse charge back through the connection. So the two pods are still tethered at some point, obviously, so you'd be able to travel back. So it's keeping their locations marked. And she says, I can send a subspace charge back the way you came and fry your actual brain on the other side, which is dark and unpleasant. So not good. But let me see if there's any more on this one. So so Five's the girl. She got to them when they were left alone after having been beat up, and she's basically like, look, I got it. I'm out. I'll stay. I will carry this technology back. We actually physically have it, so we can get out of here with it, and I'll take care of it. And she just shoots them, and their bodies go and turn into Avengers type dust. So curses, and she can't do anything to them anymore. And indeed, they wake up back on their ship, the Raza, and they don't remember anything. And so the joke is kind of like, so how did it go? I don't remember anything. She's like, so it didn't go well then. If you're back and you don't remember anything, that means you got caught and you got killed. So that is not good. Now, they rescue Five from the rooftop, as they were planning to do. She got out. She has the technology. She has this blink drive. And she gets out on the shuttle, and then they're kind of in there, and they're like, all right, well, but your body's over there, and you're here. So let's just link these two together, and then your memory should come out in the normal one, so you're not cloned. And she's like, creepy, but weird. But I think I'm okay with that. Which is a normal reaction. And she crawls into it, into one of the transfer pods, and they transfer her memories back to her original one and disintegrate the clone, and all of that matter is recycled. So just kind of idle thoughts about this. One of the things that I really like is this idea that you could theoretically, this is sort of this transporter technology, you could create clones, and you could have clones wandering around, and they would know that they were clones, but then they've taken off and done their own thing. So rogue clone idea is a possibility. And it's cool. I really like it. I like how they describe it. So before we get to the cliffhanger in the beginning of the next episode, because there's a whole more science to talk about there, few throwaway lines that I really liked from this was this kind of annoying, intentionally annoying character that they had picked up at the beginning of this episode, says that, he sort of stumbles and he's a little off base. He says, even with the inertial dampeners, all the ins and outs of FTL make me queasy. I even have a special bracelet for it. That's kind of a cool line. I like that a lot. So they have inertial dampeners in the Dark Matter universe. We've talked about those a little bit. They are a great throwaway, not really even throwaway, sci-fi technology, a good go-to sci-fi technology that allows ships that accelerate and decelerate very quickly, which you have to do in space because space is big, and additionally have FTL drives, that inertial dampeners will dampen inertia. Because inertia is the physics law, is the reason you have to wear a seatbelt. That your body wants to either stay in motion if it is in motion, or it wants to stay at rest if it is at rest. And so if your body is at rest and a ship takes off and goes to FTL and accelerates super quickly, you will end up splattered against the back because your body wanted to stay in one spot. And likewise, if it comes to a screeching halt, you will, like Bender, end up shot through the front because of inertia. So inertial dampeners are a great way to say, yeah, future, we've solved the inertia problem. I don't think they're super necessary. I think it's one of those like artificial gravity that it's fun if they include it, but we kind of let that go because we have to assume that they have some solution for it to be able to walk around safely on a ship. But it was a nice little throwaway line. And this idea that FTL drives could make a person queasy. It's kind of fun. Yeah, inertial dampeners are the seatbelts of space. That's exactly right. They're important. We must have them. Otherwise, things would be bad. But I like that idea of FTL making a person queasy because, we've talked a little bit about space travel, and one of the things with artificial gravity, the reason we don't have a rotating space station now, like 2001 envisioned, is kind of because it either has to be really, really big, which is prohibitively expensive for what type of position we're in to want to get into space right now. Or it would have to be small and rotating very quickly, and that will give you awful, awful, awful vertigo. Because your body will be fine if it's standing still. It will feel like it has gravity as it's rotating around. But the minute you move and change direction and your height is taking up a not insignificant proportion of the radius of this rotating space station, you will feel very, very ill. Because Coriolis forces are a thing, and our bodies are squishy fluid sacs that don't do super well in that environment. So anyway, space travel is complicated and has adverse effects on humans. And they kind of address this here in a weird way without going into it, but as a fun, interesting throwaway comment. It does have some, they talk about subspace. They talk about some form of subspace network, that's how these transit pods are connected to each other. So when we talk about subspace, take the trampoline. It's the area above and below the trampoline. And although our universe appears to be overall flat, for things like this, and in science fiction, we can sort of use the example kind of like, toilet paper, that it's flat overall, but there's parts where it's folded over each other and then where it's wrinkled. And so there are shortcuts that necessarily traveling along the surface is not the shortest way to get from point A to point B. And in order to do that, you would travel through subspace. Now, so this idea of a subspace comms network, even to take it to the point where it's not even necessarily the 2 points are folded on top of each other, but if we have our trampoline and we have a subspace comms network that we've somehow punctured buoys into normal space and through down into subspace, who's to say that light signals, that traditional communication methods, they're no longer limited by that surface of space-time. They're out here in happy subspace, which has different physics rules, and so even if it's not close, it's in subspace, so you don't have to travel at the speed of light to transmit data, so it could be much faster. That's another way of thinking about subspace communications, which obviously lots of science fiction uses, and we're always happy to see it. Another good kind of throwaway dialogue line that came out was this guy was reminiscing about his time where bad things happened, and he said that they came out of FTL into a meteor storm and stuff got bad. which, again, I kind of like because, here we have those conversations where we ask these types of questions, well, what if, what happens to planets in the way of a warp drive? And we don't have to get into it now, but this idea that that's why Sulu, has a job, or a Navicomputer, to be able to map things like that. But there is an element of unpredictability, and dropping into a meteor storm would not do good things to a spaceship. Meteor storms in space. So really quickly about meteors, they'd basically be small asteroids. Typically what we say is, asteroids are sort of bigger, meteors are a little bit smaller, and typically the line is a little fuzzy, and I'm not going to get super pedantic about it, but you could say meteors are the ones that hit atmospheres, and then meteorites if they make it through and they hit the surface, because they got it right. And, but there's also, I have also heard astrophysicists just be like, well, there's got to be sort of a small asteroid limit, or, if a big asteroid breaks up into lots of tiny, smaller asteroid storm, it's all, again, not something I would get super pedantic about. I think the only thing you wouldn't want to say is a meteorite, because that is specifically when it's made it through an atmosphere and hit a planet. So they have the blink drive. They have the adapter. They plugged it into their engine, and they're going to test it. They're going to try to go from point A, where they are, to point B, which is, she plugged it in, to be 160 light years away. Decent test of this blink drive. And then they go, and the end of the episode. What happened to them? This is why we did the two-parter. Now they get out of the test, they appear, and stuff's gone bad. Things are, sirens going off, hissing, electrical sparks are happening. They have micro breaches all over the ship. There's, there's FTL and there's subspace damage to the ship. And, and they're like, so where did we end up? How far did we go? Okay, ship is repairable. We haven't been sucked into space. Did we make it 160 light years? And they're like, no, we're 1.2 miles from where we started. The response is, yeah, we could have walked that. It's not wrong. But things are weird. They're not far. Excellent question. That is a excellent question. Why are they using miles? Language. Because we would expect, especially space, and actually, thank you for that question, because we can tell fun stories with that. Why they would be using miles, if we want to retcon the explanation, which I am always up for doing, as someone who gets put on shows that have included science that is less than science-y, and we have to explain. We could say that miles, because it's all about scale, right? Kilometers are smaller than miles by a little bit, but they're smaller. And on the scale of space stations, which is kind of what we'd be looking at, the scale of ships to space stations, scale-wise, miles would make more sense to use, because it's just your audience. It's your audience. I'm trying. But it's one of those things where it's you're going to say, your space station is going to be, whether it's 5 kilometers or 3 miles, it's pretty interchangeably at that point. But regardless, they're 1.2 miles. It is funny though, if you haven't heard this story before about, and the reason I can't justify this is because the space community's very hard metric. Very, very hard metric. There's a big bad, sad reason for that from the 90s when we tried to land, and I don't remember my classic names, we tried to land a lander on Mars. I don't remember the name of it. If anyone has the name of it, please throw it in the chat. But it was in the 90s. Was it the Polar Observer? I think that's right. And miles and kilometers got mixed up. The US was using miles. The Europeans were using kilometers. It programmed in... Was it... I thought there was still supposed to be an actual lander. But anyway, they were supposed to get to Mars. Yeah, I think you're right, actually. They were trying to get to Mars. Mars Polar Observer. The miles and kilometers were mixed up, and that thing buried itself on the surface of Mars. Because the aiming was right, but the distance was off, and it just plowed through, and it did end up being a mistake between miles and kilometers. So kilometers is kind of a standard for space distances these days. Although when we, and Andy mentioned, I think the aerospace, like the engineering side community does use them a little more interchangeably. But when we talk about things like low Earth orbit, we try to kind of stick to kilometers. And yeah, that's a good point. The manufacturing side, the aerospace side, the aerospace engineering side of things, because of manufacturing, does stick mostly with Imperial. And that's why. So, yeah, that's great. Great input. I love that. I think that's awesome and hilarious. And I always love sharing that story because it's just the biggest facepalm of 20th century space exploration. We'll put it that way. But I don't want to run out of time too much. Where they test it, they end up 1.2 miles being their unit of choice, which is fine. And the station that they had just departed from is dark. There's a distress signal coming out every 3 minutes and no other communications. There's no life signs on this space station. They're like, we were just here. What happened? And then through the viewport, they see a space battle going on, and it's their own spaceship. The Raza is plowing through and destroying things in its wake. Like the ship that they're currently on is out there doing bad things. And they're like, well, that's not good. They do a quick scan of this ship to figure out if it's just if someone's, has an IFF that's mocking their signature, and Anne is basically like, no, I'm detecting residual negative energy, which means they also have a blink drive. Pause. I love that. Residual negative energy. We've talked about kind of positive and negative mass and positive and negative energy. If you haven't seen this stuff before, really quick, Einstein, along with other scientists, but primarily Einstein in the early 20th century, came up with E equals mc squared. This idea that energy equals mass, that mass has energy intrinsically stored in it. And it's a lot of energy. So when we extend that to science fiction, typically in order to warp space-time, in order to get any conscious bends or dips in space-time, you need mass. You have your trampoline, you need to add a bowling ball. I have a drink here. I did the trampoline thing again. I'm well overdue for a drink, but we'll save that. So I'll make up for it after this. If you don't have a bowling ball, if you don't have any mass in order to bend space-time and you want to do something like, say, fold 2 points in space and time together, you could use an equivalent amount of energy, which would be a lot of energy because of how much energy is stored in matter. To get an equivalent amount of matter, you need a lot of energy. But now, something that we in our science, our pre-Cochrane era of science, hasn't figured out necessarily how to do that, how to warp space-time. We have postulated it, we've seen the indirect effects, we have directly detected it through gravitational waves. We have not reached the how are we going to play with it stage. But this idea of negative energy is like tachyons. Theoretical, but you have normal matter would do that, normal energy. Negative energy, you could say, bends space-time that way, and would behave in ways that we don't necessarily have physics to explain. But if you're talking about things like warp drives or blink drives or any sort of faster than light method, it's pretty easy to imagine that maybe in order to bend space-time and not use traditional energy, you could use something called negative energy that would do that. Purely theoretical, purely science fiction at this point. We hold out hope. But saying that the fact that they have residual negative energy is a sole indicator that they have a blink drive, I like that, because it's saying that, all right, our FTL drives use normal energy, use normal whatever physics that we know. This blink drive, in order to bend 2 points of space and time together and make this jump, taps into negative energy or has residual negative energy that come off of it. Kind of like how, not saying this is how it is, but it's similar to how tachyons are left over in the Star Trek universe when you use warp drive. That's sort of a similar analogy there. But we're not even to the good part yet. They detect this ship. It's got a blink drive that we know of because of the residual negative energy around the ship. They realize that they are in another universe. Boom! They're in a multiverse, and I love that. I love multiverse theory. You all know that. And what they've said, now they do kind of go in and properly try to explain it. But what happens is, first of all, their blink drive is fried, so that's not good. They have detected an anomalous distortion at the exit point. That's how Anne figures out that they're in a different universe. It's not measuring correctly. And one of the things she uses to measure this is she realizes that there's a slight variance in the cosmic microwave background. It's awesome. It's a cosmic microwave background. Without getting too much into it, if you come to my Astronomy 101 classes, we'll learn about it. But it's the residual heat left over in the universe. So Big Bang happens, universe expands, universe continues to expand, and like bread that comes out of the oven, it starts to cool off. And we haven't cooled off to absolute zero because there's some residual heat in our universe, and that's called the cosmic microwave background. The easiest way to think about it is just residual heat from having baked a loaf of bread. That's basically what it is. You started with this, it expanded, you baked it, and now it's cooling off. And that's kind of the best way to think about it. That's at least how I've reckoned it in my head. And here in our universe, because of how long it's been around, our universe has cooled down to a specific temperature of like 2.7 Kelvin. So just above absolute zero, but there is a specific temperature to it. So that would be not an unreasonable thing to test if you think you might be in another universe, is to measure the cosmic microwave background. And let's say you measure just this residual heat in the universe and you measure it to be 8 Kelvin. Something's wrong. Whatever you are in is younger, is still warmer than that universe that you came from. So that would be a good indicator that something is different. Now, last week we talked about the Star Trek episodes, Parallels, where their multiple universes all had different fundamental physics constants of nature. This is just another universe spawn that they are measuring something different. They don't go into that level of detail. They just say, we measure a slight variance in the cosmic microwave background. And something else was drastically different, as DTG says. So they do continue to expand, though, on this multiverse theory, saying that this is, and kind of touching on what you're saying, that there is a quantum multiverse that, the way they talk about it, due to different time streams. And they actually describe it really similar to how we talked about parallels last time. that you get these tiny variances, this idea that you have and in this case, using the word quantum to mean small and not discrete, but to say quantum multiverses, you have discrete, that's the correct use of quantum, tiny, that's sort of the right use of quantum, universes that differ slightly from each other, but because they inhabit different time streams, you could say from different decisions that are being made, from different initial conditions, all of those things, they would vary just depending on which universe you're at. And effectively what happened is they did not account for their temporal displacement when they used the blink drive. When they did their blink drive calculations, and I saved the best for last. I saved the best for last because I love accounting for temporal distortions. That is like, effectively what it means is it's saying that we're trying to travel through space-time. Our universe is 4-dimensional, space plus time. All we're caring about in this situation is going from 2 points in space, but they didn't account for the time. And trying to organize my thoughts here. So they didn't account for the time. We'll carry on with this. What that did is that punched a hole through all these other universes. So how could that happen if they're not accounting for the fact that they're having to adjust their time, right? Saying that it's effectively saying, all right, I'm here, I want to go here, but light takes time to travel in space, right? So light takes time to travel, and so by the time that it's reached you, it's now older, and you're seeing it as it was when it first emitted the light. Stick with me. It's essentially, I always, instead of trying to talk about like stars and light years distance, I always try to just think about our star, our sun. Our sun is 8 light minutes away from us. So the light that we get is 8 minutes old. We see it as the sun was 8 minutes ago. So how you could screw up a blink drive is to say, I want to go to this position at this period in time, forgetting that position doesn't necessarily exist anymore, or is somewhere else, or doesn't look the way it does. That was how they came up with that red line in Battlestar Galactica, is saying we're jumping to another point in space-time, and we only know with a certain amount of certainty, like to a certain distance, where everything is going to be. So that's our red line. Beyond that, the odds are too great that you're going to end up in the middle of a planet to try to make that jump. That's kind of what they're talking about here. Again, I am extrapolating this from one line that says we didn't account for our temporal displacement that screwed everything up. But I love it because it's saying it's space-time. One of my favorite Voyager episodes is the Eye of the Needle, where they have a wormhole that are connecting 2 points in space, and they don't realize and don't put it together that it's also connecting to different points in time. And that's having that as a plot twist is always happy for me. And exactly, it's the opposite of doing time travel without accounting for us moving through space, which is something I've talked about before, but I love it so much I'll mention it briefly now. That's like saying, all right, I built a time machine. I've got a time machine. I figured it out. It's awesome. It sits in my garage. And I'm going to use it, and I'm going to test it. And so you test it by going forward 1 second. You're like, all right, I don't want to screw anything up. I don't want to like mess with the space-time continuum or whatever. So I'm just going to go forward 1 second and see if it works. And if you don't account for the fact that we live on spaceship Earth, which is rotating, going around the sun, going through around the galaxy, and then the galaxy is moving through the universe, you will end up about 700-ish kilometers from where you started in 1 second. So we are moving through space about 700 kilometers a second, all told. Accounting for rotation, orbits and galaxies moving. Every second it's about 700 kilometers. Fun to think about. So yeah, effectively what happened is They said, all right, we want to go from here to here, but all we're caring about is the space. They didn't put in the fact that they also have to account for time, and that mistake punched a hole into alternate realities, and they ended up in a different universe, which is perfect. We love multiverse theory. And they essentially, they meet their own ship, stuff goes wrong. They are able to make it back basically by just it's almost, I can't believe it worked out so well that we did parallels last week and we're doing these episodes this week, because it's so similar. It's actually really, really similar. And all I wanted to do was talk about Blink Drive, and we ended up talking about quantum multiverse theory in a very similar way to how TNG parallels. I did not plan it. I'm secure enough to admit that I did not plan for how perfect that this was. The way they describe it, and then how to undo it is basically recreate all the things you did to make that mistake first, and just do it in reverse, and then you'll be fine. And they are fine. Except they brought someone back with them, which is the dun dun dun, which is why you should go off and continue watching Dark Matter, because it's fabulous. So, if there are any questions, that's pretty much what I've got for this round. I will pause and try to catch up on all my trampoline analogy drinks. But if there are no questions, if you are frantically writing a question right now, just hit enter and then keep writing it so I know that there's a question coming in. But otherwise, we can start to wrap things up. But I appreciate all of you hanging out with me. I know we're having good days and bad days. It's been a long time now. Everyone's in different situations here. And great. I'm glad that you can keep on continuing, because Dark Matter is a fabulous show. And I'm glad that you're watching it. So we'll just kind of wrap things up then. So I do want to make an announcement that I will be doing a panel with the amazing Jonathan Frakes on this Thursday. So in like less than 48 hours, which is May 21st at 1 o'clock Eastern, 10 a.m. Pacific time. And it's hosted by Explore Mars. The theme is Full Steam Ahead, Space and Hollywood. The relationship between space and Hollywood throughout the years. And it will be a conversation between myself and Jonathan Frakes and anyone else in attendance. So you can check out my social media. Again, links are down below, but I've posted links to the event if you want to get tickets. I think it will be recorded. And posted afterwards. So, but we will have Q&A section, and it should be great. I'm really looking forward to it. So thank you again for hanging out. I will, after the Jonathan Frakes event, he's a cool dude. I've been lucky enough to cross paths with him before, but like, there's always going to be that 14-year-old me that is freaking out, because he's awesome. He's objectively awesome. So anyway, enough about that. Thank you all for hanging out with me. If you're here live on Twitch, be sure to hit that follow button. And thank you for your support and hanging out. Even if you weren't chatting, it's always great to have people here. And if you are watching this after the fact on YouTube, please remember to like and subscribe and all those things. If you want to have a say in what we're discussing every week on this show specifically, that's part of the patron perks. So you can find the link to that down below. And it's a really great community. Those of you who are here, who are part of it, I really cherish every single one of you. And those of you who aren't, I cherish you too. But yeah, thank you again for watching. I really appreciate it. Take care of yourselves. Take care of each other. Get up, stretch, have a glass of water. Stay strong. We got this. Live long and prosper. All right. Until next time. Thanks, everyone. Bye.